Come on, go live. Yes. Come on, go live. I'm live on YouTube and let's see here. I'm live here as well. Am I live here? I seem to be offline on Twitch, but I'm live on YouTube. Something is wrong with Twitch. So today I try to do both, but forget about this FC25 which I have played in the past. Yeah, that's the game that I played. But why is it FC25? This is not FC25. What is this? I'm gonna remove this title. Oh my god. Learning GoLang live. Sorry guys, whoever is watching. Hey, new streamer challenges, right? Methods and interfaces. That's what we're gonna be learning today. So I'm gonna just say done. Okay, the title is now all good. But why I don't see myself? Okay, I see the chat here that I sent, but it seems like I cannot see myself here. How can I do that? What can I do? And I'm already live to I have no idea about Twitch. I have no idea. This interface looks a lot complicated. Maybe I need to do something about it. Can I browse it from my phone? There's something wrong. No, I think it's fine. I can see myself here. Okay. Apparently. Okay. I'm probably okay live. Sorry for whoever is watching this at this point. It's just a struggle to get things working properly, and yeah. Now I am live. And I'm alive as well. And we are having 11 million subscribers here. So we are growing, because last time we checked, it was 9 million. Now we are 11 million. We are gonna go. We got the Twitch thing going. That's brilliant. Maybe this one doesn't show for me because I'm the host, maybe. I don't know. But anyways, I could see that from my phone it works. I hope you can hear me well as well. Why is this? Look at the title, man. Look at the title. Learning GoLang live. Methods and interfaces. That's what we're gonna be learning, and I'm gonna remove this description. No, it's not made for kids. Category. Well, not playlist, doesn't matter. And save. Okay. Now if I click on it, yes, yes, we are good. We are good. It will take me a while because I just learned about restream a little bit, that I could do multiple stream. And yeah, I don't see, do I see any restream logo around? Because I'm using the free version. I don't think so. I think it's probably fine. Anyways, welcome everybody. My name is Rashid. I'm an SRE, but I'm a Go struggler because I struggle with Go quite a lot. And during my past streams, uh, I learned Go and I struggle with the exercises. Last exercise, we solved Fibonacci using closures, which took me 2 hours. Quite frustrating journey, honestly. And this is my implementation. Even my implementation is not the best, but it works. That's totally fine as long as I got it working. Maybe there are shortcuts, and instead of defining variables like this, I could do something else, obviously. But hey, we got it working. That's the most important thing. And I just want to say the congratulations, to encourage ourselves to go even further. So congratulations, you completed the lesson. Thank you, GoLang. And we are going to go into methods and interfaces, which is an interesting topic to me. We'll see what they are about. Yeah, so we have gone quite further with a GoLang documentation, or a tour of Go, basically. This is not the documentation, it's a tour of Go. We just jumped right into tour of Go, maybe something we shouldn't have done because we struggled quite a bit with a lot of concepts as a new programmer. Yeah, to be fair, I have been writing program, and during my career, I'm writing scripts, Bash scripts, Python scripts, but in real world, you don't kind of face this kind of challenge, and that I faced, for example, with the Fibonacci implementation or a square root function, things like that. A tour of Go involves quite a lot of mathematics, and that adds to the complexity. The terminology is also a little bit more complex, but hey, we are going forward. We are learning a lot, so it's okay. And yeah, let's click on methods and interfaces now, which, oh my God, it's a lot more than I thought, because I didn't click on it. I thought it's just one, one single exercise, one single item, but it seems to be a whole section. And then after that, we're gonna learn about generics and concurrency. But for now, we are gonna go to the methods and interfaces. But why I cannot? Okay, here. All right. I have my new Vim also already here, and with our Hello World program. Maybe I need to create another file. Okay, I could do it from there directly, but it's okay. I will just say methods and interfaces dot go. In Vim methods, this is where we're gonna write programs. Import, of course, package main. Also, if I want to name this that main, I need to rename this to something else for now. All right. And I want to go methods and interfaces here. Import the FMT function, FMT module, and now we're gonna define our func main and fmt.println hello world, in case you don't know how to write hello world program in Go. All right, but we are not here for that. We are here for methods. I wonder if my chat is connected, because I see here, I put my chat here, but my chat is here. But if I send a chat from YouTube, will it end up here? I don't know. I really don't know. Let's try. Let's try. Hello, everyone. All right. Now if I go back here, okay, I don't see anything. I think this is just coming. Oh, it's coming from, nice. So we have both YouTube and Twitch chat in the same place. So that's nice. That's brilliant. Let's silence our phones as well. And we are ready to go. Okay. All right. I hope you can hear me well. This thing gets on my way. Sometimes I don't know where to put it, honestly. But it's fine. Okay. Before I jump into this, I just want to make I just want to tell you what's my understanding of methods and interfaces. I don't remember exactly about interfaces, but methods were in programming languages like Java. Methods were the properties of a class, right? It were the methods in Java were functions that belonged to a class, right? And like, for example, a cat has properties like eyes, color, I don't know, and then a cat walk, right? That walk can be a method, which is a property of an object like a cat. That's my understanding of methods. Interfaces, if I remember correctly, were sort of halfway through implemented classes, if I'm not mistaken, and then you were just these are all from when I was doing university 10 years ago, and I never opened the book again and didn't read them because I jumped into Python, and yeah, um, I use Python for scripting, which doesn't involve a lot of deep, like it doesn't. I didn't create fully functional applications. Sort of like I didn't build Django applications. It is just basically Python scripts for automation or for monitoring, right? So today we're gonna learn a bit about methods and interfaces and see how they are done in Go. So Go does not have classes. However, you can define methods on types. I think the extract, right, that we talked about is to me like a class. So again, here I can relate these two things. A method is a function with a special receiver argument. The receiver appears in its own argument list between the func keyword and the method name. In this example, the apps method has a receiver of type vertex name v. Okay, so first of all we have a type, and both of this type has two properties. It's vertex, obviously it has x and y property, both of them are float, and we have a function. I think here is where this receiver, right? So this is receiver, I think. This parentheses v for vertex, this is a receiver, so it means this function is a property of this function is a method of type vertex, right? And it's an absolute. The name of it is absolute, ABS. And also it's interesting that it's capitalized. That would mean something. If I remember correctly, that would mean this function can be used outside of this this package, right? If another module or import this package, they could use this apps class, which is the whole point, in my opinion, right? So maybe that's why it's capitalized, and it returns a float 64, and it basically returns a square root of v dot x, right? This guy here times v dot x plus v dot y times v dot y. And in the function main, we simply initialize this type here with values of 3 and 4. So this 3 and 4 are going to be assigned to x and y here. And then we are going to see this method, v apps. Okay, this is very interesting. All right, I think I understand it, but I could be wrong. Let's go back to our new Vim here and try to understand and try to make our vertex type. So I will just type vertex is extract, right? And it has two properties, x and y, both of which is float 64. Okay. Now is the time to define that function, v vertex, right? The function name is absolute, and it doesn't take anything as an argument, but it returns float 64. And here we're gonna return, obviously we also need math, because that is coming from math library. Oh, no. I don't want to come here, sorry. Back here, because I pressed the wrong thing here. And return math dot square root, math dot square root, right? Yeah, square root of v dot x times v dot y, v dot x, sorry, because we want to yeah, basically we want to multiply the number by itself, and we want to do the same for y as well, times v dot y. Okay. What does it say here? Obviously this is x capital letter. The issue is solved. And here, now we need to initialize v. V equals to vertex, right? Let's put 3 and 4, similar to the documentation. fmt dot print line v dot apps. So we are accessing the method. Two arguments is in conversion to vertex. Wrong argument count. Obviously this is not parentheses, right? This should be, because this is an extract, it should be curly brackets. I always get that wrong, but here we go. What are the chances of us getting it right? I'm quite hopeful, but obviously this is sorry, go run man. Okay, 5, that's good. So 3 times 3 is gonna be 9, plus 4 times 4 is gonna be 16. So 9 plus 16 is 25, right? And then the square root of 25 is 5. We got it right, I think. All right. Let me see my OBS. Does it show anything? This is, yeah, the reason in the first place, the reason that it didn't work for me was because, see this title, I needed to update them. I updated it here and it didn't work. So again, I don't know if anybody's in the chat. I don't think so at this point. It's only me. But share your opinions with me, guys. Anybody who is watching, all right? Or if you're watching this later on, make sure you comment out. Share your struggles, your pains, similar to how I do, you know. And yeah, I could learn one or two things from you guys as well. So if I run this, it's going to be 5 as well, right? Again, for those of you who are joining me, I don't like here to type here because it's not very friendly. It doesn't have auto completion for, I don't know, like double quotes and stuff. And that's why I always go back to my new Vim and do stuff there. Methods or functions. Remember, a method is just a function with a receiver argument. Okay? Okay, let's go back here. So this is exactly a simple function, but we have this extra thing here, which means which is called a receiver, and that is of a type vertex, and this type is obviously custom that we have defined here, and we name it v, right? So this v, obviously this is similar to something like this, right? So v dot x axis whatever value that we pass to this vertex whenever we initialize it. Yeah, and then v, same goes for v dot y. I think I understand it. Hopefully there's nothing confusing here as well for you guys who are watching. But a method is just a function with a receiver argument. Here is apps written as a regular function with no changes in functionality. Yeah, nothing has changed here, except here. Wait a minute. Oh yeah, yes. See here, this apps function, it takes a v argument of type vertex, right? Yeah. So receiver. So these arguments, these parameters, if I want to change it, I will just bring it here, right, like that. And I think here it should we should signify this is a function. Run it and define apps. Okay. How did we do it here? Yeah, that's how we did it, right? Apps, obviously here we don't need argument. Okay, undefined v. V vertex. What changed? Why it doesn't work? Declared and not used v. Oh yeah, here, of course, right? We declared but not used v. So that's why maybe here we need to do v dot apps maybe. Yes, that was correct, v dot apps. Because in that case, v is going to be a property of absolute function, similar to what we did here. Okay. You can declare a method on non-struct types too. Interesting. If a type is not struct, you can define a method for them. In this example, we see a numeric type, my float, with an apps method. You can only declare a method with a receiver whose type is defined in the same package as the method. You cannot declare a method with a receiver whose type is defined in another package, which includes the built-in types such as int. I don't know if I understand that. But if we look at here, I think we know. So here we have a type called my float type of float 64, and here we are making a receiver of this type, right? We pass a receiver to absolute function, and we say if is less than 0, return minus f, right? Float minus f, otherwise return f. Is this shortcut for math.square root of 2, or what is this 2? Is this something like math.square root of 2, something like that? Does it work? It looks like it worked, but if we reset and run it again, yeah, it's the same. Okay, that was a shortcut. I'm not fan of shortcuts because it gets people confused. It makes especially a beginner confused. I would like to go the full circle. I want to experience the whole thing, and then later on, once I get comfortable with the syntax, once I understood the concept, then it's okay. I will slowly and gradually pick up these shortcuts and use them more often. But in the beginning, it's kind of confusing, which, yeah, I don't like this kind of documentation where, yeah, they introduce something like this without explaining, because it's going to get you confused. But let's implement that. All right. So what I will do is uh, let's completely delete this from here to here, and I will just have a type of my float, which is this. This is also a new concept to me, right? Because I thought extracts can be only type can be only for of extracts, but it doesn't have to be. Here we have a type of float 64, right? And we have a, now we have to define our vertex function, sorry, our absolute function, right? So this is our receiver, and then we have absolute, and here we're gonna check if f is less than 0, right? We're gonna return math dot square root, yeah, square root of minus f. Why undefined? Math dot square root, man. Oh, it's capital, sorry. Square root of minus f. Too many arguments, too many return values. I need to check. Oh, sorry. Why am I doing this? Here we are returning a minus f because that's of type my float. So we just return a float 65, right? A 64 of minus f, which is of type my float. Okay. Return something like that. Too many arguments. Why? Wait a minute. Otherwise, return float 64 of f. Why it gives me this error? Obviously, because we forgot that this function returns a float 64. That's why. And function main. All right. Now we need to initialize our float, right? So let's say if equals to my float math dot square root of 2, this guy, which again is shortcut. Let me fix it. I just don't want this guy like that. All right. And now we can use it. We can use that. fmt dot println f, right? We can do that. F dot apps, obviously, because that's what we are looking for. Okay. Yeah. When you write things, then things seem a lot more difficult. But if you just look at things from the UI, from the documentation, it's like, I understood it. But actually you don't. You need to jump into implementation. You need to get your hands dirty to really understand it, because now I understand it properly. All right. So here we are specifying a type of my float, a type called my float, which is of a type float 64, right? And a function. Again, the whole point of this is that to tell us that, hey, it can not only be used with extract, it can be used with other types as well. But there is a condition. The condition was that as long as this is not defined in another module. Are we good? You can only declare a method with a receiver whose type is defined in the same package. So this, if my float cannot come from another package, basically. Correct me if I'm wrong, guys. Let's look at the chat. There's still nobody, but that's fine. Later on, people are gonna watch this. But I'm super happy that I got the Twitch thing going, even though it doesn't show anything here. It's fine. It shows offline quite interestingly, even though you can see here I'm live for 33 minutes already. All right. Right, let's see. You cannot declare a method with a receiver whose type is defined in another package, which includes the built-in types such as int. Okay. Okay, got it. So these, for example, if you want to, let's for example give it a try in our here. So what I will do is, for example, type my int of type int. This cannot be done. Oh, is that what it means? You cannot declare a method with a receiver whose type is defined in another package, which includes the built-in types such as int. So it says that int itself is, obviously you can do something like that because that's my int, but you can not use here, for example, I will just say int, something like that, right? That's an error. Cannot define new methods on local and on non-local type int, compiler error. I think that's what they mean. That's what they mean, right? In this case, it's just my float. Okay. Okay. I think we got it. We got it. Let's go to the next lesson. Pointers. But I thought methods and interfaces are such a short, lesson that I named the whole stream method and interfaces. All right. But look at here. But it's okay. We can rename it methods and interfaces part 1, something like that. It's fine. Later I will do it. But we will see how far we can go. Pointer receivers. So we already know about pointers, right? We learned in the previous stream. Pointers are still scary to me, but I think I understood them. So we did a lot of, we worked with them. We did an exercise on them, I believe. So we have some okay understanding of pointers, but let's see what pointer receivers are. You can declare methods with pointer receivers. This means the receiver type has the literal syntax of type and obviously asterisk type, which refers to the value of the memory address, right? Ampersand t, for example, is the address itself, and asterisk t means the value that's placed on that address, if I'm not mistaken. Okay, this means the receiver type has the literal syntax of this and some type t. Also, t cannot itself be pointer, such as something like that. Asterisk int. For example, the scale method here is defined on vertex. Methods with pointer receivers can modify the value to which the receiver points, as scale does here. Since methods often need to modify their behavior, pointer receivers are more common than value receivers. Okay. Try removing the asterisk from the declaration on the scale of the scale function on line 16 and observe how the program behaviors changes. With a value receiver, the scale method operates on a copy of the original vertex value. This is the same behavior as any type of function argument. The scale method must have a pointer receiver to change the vertex value declared in the main function. Okay. I didn't understand any of that, honestly. We need to read it again probably, and we need to look at the example to understand it better. But let's look at the example. I think we will understand it better, a lot better that way. So here we are defining a type called vertex, which is an struct, and it has two properties, x and y. And we have a receiver of type vertex, right? And the name of the function absolute or abs, right? Abs, and it returns the math.square root of x times x plus y times y, right? Here is where we are passing, here we are defining another function called a scale, right? Which takes well, what is this f? Is this an argument or this is a return type? And this is where I'm getting confused. I think this is not a return type, but a parameter, right? A parameter, not even an argument. An argument is when you initialize a function and you pass value, and a parameter is the function declaration, right? The variables in the function declaration. Okay, so in that case, here is the important part because we are passing the value of vertex in the memory. We are passing, well, based on my understanding, this asterisk means the value of an address. In this case, the value of address vertex. But where is vertex address defined? Okay. Okay, for now, let's assume that this is the value of the memory address, and we just take v dot x equals to v dot x times f, which is the float that we accept here. Same for y, and we pass 3 and 4. This is a square root of this is going to be 5, right? And then we're going to scale it to 10 and see what is the behavior. 50, right? 5, because in that case it's going to be I don't understand this, sorry. I don't understand. If I remove this vertex from here, this asterisk from here, it's going to be 5, right? It's going to be 5. Okay, because in that case, okay, I think I'm getting there. I'm getting there. It means it is 5 because this scale function is kind of doing nothing here in that case, right? Because we are just basically, it is doing something, but it's not printing anything because we still access the vertex apps, which is literally this one. So we are not doing anything with the value, but if we are not doing anything with the scale. But if you put an asterisk here, in that case, it means the memory, the value of vertex in the memory. And if we scale it, obviously this is a pointer to the same underlying memory location, right? And that's why this changes it, right? So let's now read it again. Maybe now we will understand it. You can declare methods with pointer receivers. This means the receiver type has the literal syntax asterisk t for the for some type t, right? In this case, it's vertex for in our example. This means the receiver type has the literal syntax of this, which we have exactly defined here. Also, t cannot itself be a pointer, such as asterisk int. Okay. For example, the scale method here is defined on vertex. Okay. The scale function is on a pointer to a memory address of vertex type. Am I getting that right? Methods with pointer receivers can modify the value to which the receiver points, right? Method with pointer receivers, right? Like this method, this method, such as a scale. Methods with pointer receivers can modify the value to which the receiver points. Okay, so this receiver points to the value of a memory address of vertex, right? And, okay, since methods often needs to modify their receiver, pointer receivers are more common than value receivers. Since methods often need to modify their receiver, I don't understand this part. Since methods often, I always get confused with that. Let's do the pronunciation class. I should have done that. I should have done this years ago, man. Often, man. Often. But I think I have heard often from probably Brits. I don't know. Aussies, Brits. It's often. It's often. This is also an English class for me. Besides learning Go. Okay, we are getting sidetracked again. what I'm not understanding is this statement here. Since methods often need to modify their receiver, pointer receivers are more common than value receivers. Okay, so it means this is more common than this one. Is that what it's saying? Pointer receivers, which is here, are more common than this one. Since method often need to modify their receiver, pointer receivers are more common than value receivers. Try removing the asterisk from the declaration of the scale function on line 16 and observe how the program's behavior changes. With a value receiver, the scale method operates on a copy of. Okay, this explains it, I think. With a value receiver, right? The scale method operates on a copy of the original vertex. So here, if we have something like that, this is a value receiver. It copies this to, obviously this is like a new definition of type vertex, if I'm not mistaken. So that means it's a it resides in a different memory location. That's why whatever you do with it, it does not impact the original value, right? With a value receiver, the scale method operates on a copy of the original vertex value. This is the same behavior for any other argument. The scale method must have a pointer receiver to change the vertex value declared in the main function. Okay, so here we are declaring a main function, right? And we are scaling it. Forget about what a scale does. It's just basically multiplying the values with number 10 here, okay? And here, if we don't put a pointer here, it means this is going to create a copy of the vertex of this, right? v.scale is going to create a copy of this original vertex v, and it's going to operate on that. But here we are still printing the v.apps, which means it is still pointing to the old memory address, or the old value, sorry. Hey, it's not easy to, I think I can, let's clear the board. Let's clear the board and let's copy this whole thing there. Try to understand it better. Okay. Okay. So when we define something like this, right? This is gonna be somewhere in memory, right? This is our memory, RAM. Okay, so let's say this in the tab here. Okay, this is V. Okay, now when we do v.scale10, if we don't have this asterisk sign, what does it mean? It means we are creating a new memory location. We are copying the value of vertex. This is this default behavior of any function argument. So we are gonna, let me use different color. We are bring this here to here, for example, right? This is gonna be v.scale, right? v.scale. And whenever we do that, the operation like this, these two operations, right, is happening all here. So that's why when we print apps function, it's just gonna return still the value of this memory. So this v.apps, right? So this v.apps points to here. It never goes to here. Okay? So that's why if we remove this here, it's still printing 5 because it operates on a different memory location. It operates here, which we don't have access to. But if we, let's say, obviously, if fmt dot print ln here, what is it gonna happen if we print ln that? No value used as value. Sorry. Okay. Let's do one thing. I will just say y. We need to define y. Let's say, I don't know, 3 and 6. I have no idea. We are just going to give it a try. Here, still, no value used as value. This is wrong. This is wrong. Because, why? Why I cannot print v.scale10? Can I assign it to a variable like this and print that, or it doesn't matter? It should be giving the same error, right? Yeah. Syntax error, missing a statement after label. Sorry, this is wrong. Something like that. Wait a minute. Why are we doing this, right? We need to initialize. Okay, I need to ask ChatGPT. I need to ask ChatGPT reset. Okay. Okay. If we remove the asterisk from the receiver, my understanding is that it works with a copy of v. So therefore, when we print v.apps, right, it does not show the scaled version of v, right? That's one thing. And how can I access the scaled version of v in the memory? Is my question valid? The core concept you're referring to involves the difference between value receivers and pointer receivers. Oh, okay. Okay, of course. In Go, when you define a method with a value receiver, it works with a copy of the value, while a pointer receiver works directly on the original value in memory. Here is a breakdown of what would happen in your code with and without the pointer receiver. So if we have it like this, when we have the pointer receiver, when you call v.scale10 in your main function, you're passing the address of v, a pointer to v. So any modification you make to v inside the scale method will affect original v in memory. Okay, this is why after scaling, the apps method will print the scaled version of v. And with value receiver like this, if you change the receiver to a value receiver, then when you call v.scale10, it will operate on a copy of v, not the original v in memory, which is correct based on our understanding. As a result, any changes to the field x and y inside scale will not be reflected in the original v in the main function, because you're modifying the copy of v, not the original one. So far, our understanding is right? I just want to know how we can access then this copy of that copy, right? How can we access, right? If you're using a value receiver, the scaled version will be lost because you're only modifying a copy of v. Ooh, interesting. If you're using a value receiver, right, the scaled version will be lost because you're only modifying a copy of v. If you want to modify the original v, you must either use pointer receiver or explicitly pass a pointer to the value. Okay. If you're using a value receiver, and though this is less common, like it means we just need to pass this, where is it? The original v is modified here. Should print 50 as the original v is scaled. Okay. 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 In summary, to access the scale version of v in memory, use a pointer receiver in the scale method. Okay, my question is not valid. My question is not valid, probably, because this v.scale, obviously, if you want to access it, you always need to use this here. That's what I'm understanding, if I'm correct. And yeah, otherwise it will be lost. Simple. What I want to say is, since methods I want to clarify this bit now. Can you simplify this explanation? Pointer receivers are more common than value receivers because methods often need to change the value of the receiver. Obviously, I think this makes sense, right? You don't want to work with a copy of the value. You just want to directly work with the value. That's why pointer receivers. Okay. A pointer receiver allows the method to modify the original object, while a value receiver works on a copy, so changes aren't reflected outside this method. In short, pointer receivers let you modify the actual object, while value receivers only work with a copy of. Are there use cases for value receivers? There are definitely use cases for value receivers, and in fact, they are useful in certain scenarios. Here are some key cases. 1. When the method does not modify the receiver. If the method does not need to modify the receiver and only need to read its value, a value receiver is often more appropriate. It works on a copy of the receiver, so there is no risk of unintentionally modifying the original object. Very interesting, right? That's one thing. So basically, the only one of the cases where you might not pass that little asterisk to as a value receiver is when you just need to read the value. So what happens is, in memory it will be copied to a new location, and then it's going to be read from there. But I still have question there. Why would again, the purpose is not in unintentionally modifying the original object. Uh, so it means if you're a careless person, right, you don't want to work with the original data. Here's an example. So we have a type of point is struct xy float 64, like 2 points. Function p point. Here, as you can see, we are passing a value receiver, the distance, and this is the function name distance. It returns a float 64, math.square root of blah, 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 blah. All right. In this case, the method just reads from point and returns its value. So whoever function that's going to be calling this, right, when we initialize this and pass some values, and then when we want to just simply read the values, then we're going to pass this receivers. This is exactly why am I asking this question, because obviously if I go one more here, this is simply a value receiver. This is simply a value receiver, right? This is one use case of it. There is use case of it, but I think what got me distracted is here, since methods often need to modify their receiver, pointer receivers are more common than value receivers. Okay. Let's check our chat. Anybody here? Nobody here still. That's fine. Okay, I think we understand it. Okay. But I want to, when the receiver is small, simple struct, okay? And this is another use case. When you want to prevent modification of the receiver, obviously, for consistency with working with other types, when the object is immutable or not likely to change. Summary. Use value receivers when the method does not need to modify the receiver. Okay. Give me an overall use cases for pointer receivers in real world. Pointer receivers are very common in Go, especially when you're working with more complex or mutable objects. Here are some real-world use cases for pointer receivers. First, modify the receiver's state. The most common reason to use a pointer receiver is when you need the method to modify the receiver's internal state. This ensures changes are reflected in the original object, not a copy. Okay. Here we have a type of bank account struct, right? We have a balance of float 64, and here we have a receiver, a pointer receiver, and it takes the function name is deposit. It takes an amount of float 64, and it returns. Basically, it adds the amount to the balance. All right. Now we have a bank account withdraw, we have a function called withdraw with a bank account receiver, right? Again, amount 64. Yeah, basically it's the same thing, but it's just doing it minus, right? Withdraw. Here the deposit and withdraw changes the balance. So we use pointer receivers to modify the actual bank account objects. Okay. Okay, I think I understand it. Sometimes I try to make things complicated in my mind for some reason. Like we all do, right? But it's not that complex. It's just simple. But I'm just worried that I'm missing something and I'm not understanding the use case. But it shouldn't be like that. I understand what it means. When we have an struct, especially a struct, and we want to play around with the values of that extract when it's initialized, right? Then we use pointer receiver, because then it will modify the original values in the memory. Look at our example here. So with vertex, with asterisk, with this little guy, it's gonna work. Yeah, it's gonna work directly in memory wherever that object is located. Otherwise, it's gonna work with a copy of it here. Okay. Efficiency with large extracts. When working with large extracts, passing a pointer to an extract is often more efficient than copying the entire extract. This is particularly important when extract contains many fields on large data structures like arrays, slices, or maps. Example, we have a type of video, which is an extract, and it takes a title, a duration, and comments, which is a slice of strings. Okay, so we have a video type, and what we need to do is we have a comment, right? We have an add comment, and this add comment takes a string called comment, and it adds the comment to the initialization, right? Like this v is going to be initialized somewhere, right? And then it's going to add it v.comments, where we want to add to the v.comments here, and what we want to add, the string that we passed to this video, okay, to this add comment. Here, using a pointer receiver helps avoid copying a potentially large extract video, especially when adding comments. Brilliant. Now we know more. Consistency in methods that need to modify a state. If your method needs to consistently modify the receiver, using pointer receivers ensures that changes are reflected throughout the program. This is particularly useful when you have a class like a structure, a type with methods that mutate its state. Okay, as an example, we have a counter struct. It has a value of integer. We define a pointer receiver, right, of named increment, and we just do C++. It's just in memory, basically adds the value of it. And we have a C decrement. Okay. In this case, each method modifies the counter's value. So pointer receiver ensures that changes are made directly to the original copy, right? I think it takes us back to the balance, the bank account balance that we saw a couple of examples earlier, where when you add to the balance in a bank account and withdraw, you make sure your changes are done on the original object in memory, but not on a copy of it. Otherwise, when you withdraw, the guy is still rich, you know. The guy will be still rich. Can you think of the consequences of that? I withdraw 100,000 euros, which I already have in my bank account. And what happens is, if I forget this little guy here, right, then my application is going to copy the extract of that bank account and work with it, decrement it in the copy, but without originally modifying the original value. Disastrous, obviously, disastrous. Don't do that. Avoid copy for interface implementation. We haven't talked about interface, so I'm not going to go. This guy, ChatGPT, he loves to give a lot of examples, which I like it. It's a lot better than just learning here, because it's very confusing. I got it, but I had to read it multiple times to understand it. But here we are good so far. Okay, so let's move on. Pointers and functions. Here we see an absolute and a scale methods rewritten as functions. Again, try removing the asterisk from the line 16. Can you see why the behavior changes? What else did you need to change for the example to compile? If you're not sure, continue to the next page. Okay, let's figure this out. Let's figure this out. I still need to work on this because it just keeps escaping from me. Okay. Let's find out this one. This one is an interesting one. Try removing asterisk from line 16. Can you see why the behavior changes? What else did you do? What else did you need to change for the example to compile? Okay. This time we are just simply having normal function, a function called absolute, right? We have a v vertex. It takes a value of type vertex and it returns a float 64, and basically it's a simple square root function of that value that we receive, right, times itself plus the second value times itself, right? Because this extract, this v is gonna have two floating points, x and y. All right, now we have a scale. This scale, this time, what happens is it receives a pointer to the value of v, right? It is directly, I don't know what is the terminology this? Let's see. How do you read this? What do you say this? How do you say this? Is it a pointer to vertex? Yes, it's a pointer to vertex. You should say pointer to vertex or pointer to of type, a pointer of type vertex. Okay. Okay. What confused it? Sorry. What I'm confused is the ampersand, right? But ampersand is the address. So what we say, v is a vertex. It says a pointer to a vertex. Isn't a pointer the memory address itself? Using ampersand vertex as an example. All right, the asterisk vertex should refer to the value, not the address itself. So the terminology gets a little confusing here. This is a pointer type to a vertex. It means a pointer to a vertex, right? The asterisk here is a type, is used to declare the type of a pointer, the type of the pointer. Okay, it means that the variable holds the memory address of vertex. Okay. Example like this. This is the address of the variable v, and the ampersand gives you the memory address where v is stored. Okay. The asterisk in front of a pointer variables like p is used to dereference the pointer, meaning you're accessing the value at the memory address of the pointer. Okay. Okay, my understanding is right. We are on the right track. It's just about the terminology. I wanted to get it right. Okay, that was all. All right, we are back here. We need to see what is this about. Okay, so we have the scale function now, and we are working directly with the value of vertex in memory. And this accepts a vertex, right? A v, a pointer to v, right, and a floating point called if, and we are doing some calculation basically. And here, look at here, we have ampersand v, right? So we define v as of type vertex. So this little guy 3 is going to come all the way here, and this 4 is going to come all the way here. So x of vertex is going to be 3, y of vertex is going to be 4. Now let's scale ampersand v and 10. When we say ampersand v, right, here we are passing the value of, okay, scale ampersand v. So here ampersand v is the literal address of v in the memory, and we're passing it all here. So here is the memory address and the floating point, and which is 10. And if we say absolute v, what is it gonna happen? It's gonna return 50. Okay, if we remove this vertex here, this asterisk here, it's gonna be returning an arrow. Cannot use ampersand v value of type vertex as a vertex value in the argument to scale. Why? Let's understand why. Because this is the memory address of v, so it's gonna come here. This is gonna be a really this accepts a type, a v, right? A v of type vertex, but we are not passing a type of vertex. We are just passing a reference to the memory, right? We are passing the memory address. So that's what I'm understanding. That's why. So in this case, this won't compile because we are literally passing the memory address instead of the value of the instead of pointer to v or value of v. What else I'm missing? You're on the right track, but let's clarify a few things about your code and where this issue is coming from. You're trying to pass the address of v, right, to a scale function, but there is an issue with how you define the scale function. A scale function, you defined something like this. So here v is a value receiver, meaning that it works on a copy of v. The original v is not modified. That's the first thing that we missed. I did not mention that when I was explaining this here. Okay, so passing nv in the main function, you're passing the nv, the address of v, to the scale function. However, since the scale expects a value of type vertex, not a pointer to the vertex, it will result into a type mismatched error. This is what I got right. Okay, the fix is to fix this, you'll need to adjust the scale function to accept a pointer to vertex, because we're passing a pointer when calling it. Here, because we're passing a pointer. Yeah, now it makes sense, because here we are passing past the address of v to a scale. So it's gonna come here, obviously, and here we are here we are accepting an address. We are accepting a pointer to vertex, right? A pointer to vertex. That's why we are passing ampersand v. This brings us back to the whole ampersand versus asterisk thing, because ampersand is the memory address where the value of vertex is stored. And how we know the value of vertex is by asterisk v. But these two, I think, are correlated. So that's why you can pass, because this is a pointer and this expects a pointer, right? Okay, should not work as v has been scaled. Okay, scale accepts a pointer, right, which allows you to modify the original vertex object. Okay, Let me clarify this one first. This means vertex is the value of a pointer. Earlier, I got confused about calling it a pointer because I was thinking of ampersand to be a pointer. So the memory address of v goes to the scale function, and Go runtime checks the value in that memory address. I was expecting a value of v because of the asterisk symbol, right? Not a literal pointer. That was the confusing part. All right. But we need to learn. We need to move a little bit. Okay, solution 2. Solution 1. Okay, we got it. Solution 2. If you want to keep the scale as receiver value, this is probably going to answer our question. If you want to keep the scale function as a value receiver without changing its pointer, then you would need to pass v directly and not address of v to scale. However, in this case, scale would only modify a copy of v and not the original. Okay, it makes sense now. I see where the confusion is. Let's clarify this point step by step, as it's a subtle but important concept in Go. You are right that asterisk and symbol can be a bit tricky at first. Okay, I'm happy that I'm right on something. Okay, key concepts. The asterisk symbol is the asterisk symbol in asterisk vertex. When we say asterisk vertex, this is a pointer type. It refers to a pointer to a vertex. It's called dereferencing, right? It's translating, basically. It's translating a memory address to a value. That's easy to understand. It's a translation, basically. The asterisk here means a type. The type is pointer to vertex. It holds a memory address where vertex is stored. The AND symbol, the AND operator is used to get the address of the variable. So ampersand v gives the memory address of v, which is a pointer. That's why I'm confused, right? Because maybe we should call this one a dereferencer or a translator, and this one is like the pointer, because a pointer is a memory address, right? It's a memory address. The asterisk symbol, when dereferencing, when you already have a pointer like asterisk v, the dereferencing operation it allows you to access the value stored in the memory address. Now let's walk through the exact situation. Your scenario, your function has this v vertex. This means the function scale expects a pointer to a vertex, a memory address pointer. So that was the confusion which I already got. So it doesn't mean that this one is a value itself. It means a pointer. If it was a value, right, then we would pass a value. Then it will be called a what is it called? It will be called a value receiver. It will be called a value receiver. But now it's called a pointer receiver because it expects a pointer and it translates it to the value. So the v is a pointer. It holds the memory address of a vertex, not the actual vertex value. When calling a scale and ampersand v and 10, ampersand v, the AND operator here is used to get the memory address of v, meaning you're passing the pointer to v, right? Again, that's why I said pointer to v. Yeah, I will just say after this, I will call vertex at the referencer. Dereferencer, not a pointer, because that will confuse me, as the pointer is ampersand v in my case, not in my case. So ampersand vertex basically translates the memory address to the underlying value. I'm wrong. Terminology breakdown. Pointer, when you use vertex in Go, we are referring to a pointer type. This doesn't mean dereferencing. Rather, it means a variable that holds the address of a memory location. It's a pointer to a vertex object. Okay. Dereferencing. The asterisk symbol in dereferencing refers to accessing the value at the memory address held by a pointer. When you have a pointer asterisk v, you can dereference it to access the actual value that the pointer refers to. This is called the dereferencing part. Example, asterisk p equals to first vertex 1 and 2, means you're assigning a new vertex value to the location that p is pointing to. Okay. Address of operator. The address of operator. The ampersand operator is used to get the address of a variable. So ampersand v gives you the memory address of the variable v. So let's put it this way. Whenever we see something like this of type vertex, right? This means, let's say this is an argument, right? This is an argument. This means it should be the value, right? The value that we pass should be a memory address, like 0x14 blah blah blah. Like this is a memory address, right? And if we do something like, for example, a pointer p equals to vertex. I know you cannot see it now, so let me move it this way. So if we have vertex, let's say 3 and 4, right? This is called dereferencing, because now we are assigning 3 and 4 right to the value of p. We are assigning 3 and 4 to the memory address of p. What does it say here? You mean you're assigning a new vertex value to the location that p is pointing to a location that p is pointing to. This means a location that p is pointing to, right? Okay. The ampersand operator, I think the more I read, the more confused I get. In conclusion, ampersand vertex is a pointer to a vertex, pointer type, right? Ampersand v is the address of v, and ampersand v dereferences the pointer, meaning you access the actual value at the memory address pointed by v. Okay, I got it. So here, if we say an asterisk v, right, that means is dereferencing the pointer to access the value stored at the memory. You only use asterisk v when you already define a memory address, right? So you should already have a memory address. After that, you can asterisk v so that you know the value of the address. So v must be an address, right? So if I do like this, it means v should be a memory address defined by ampersand v, right? And when I use pointer type like vertex, that means it the value of it should be a memory address like %v. Am I getting there? You're very close, and I think you're starting to get a hang of it. Let me clarify things a little bit more to ensure everything clicks. Asterisk v dereferencing, when you use asterisk v, you're dereferencing the pointer v, meaning you're accessing the value that v points to. For this to work, v must be a pointer. Example, v must hold the memory address, which we are good. We got it. That example is like this, right? So var v is type vertex. V is a pointer to the vertex. V is a pointer to vertex. It holds a memory address. Okay, and this, it means the reference is v to access the value at that memory address. Okay, in this case, asterisk means the memory address, and v to access and modify the actual value stored in the address. Address of operator %v gives you the memory address of v, which is the pointer to v. If v is a variable like v vertex, ampersand give you the memory address. Okay, I understand that as well. Like that, this gives you the address. Okay, pointer type, when you use pointer type, vertex, asterisk vertex as a type, you're defining a pointer to vertex. Okay, this means that the variable of type vertex will hold a memory address pointing to a vertex. Okay, vertex. Okay, let's just go with our explanation. I think it's in the next page. Okay. I think this is going to be probably clarifying it a little bit. Hey, what is this? What is this? Cheap viewer on a stream. Streambo.com, remove the space. Whoever, this is a bot or what? What is this, man? I will never do that. Whoever is. Yeah. Bots are in my streams. It's coming from Twitch. Interesting. Anybody watching me? Or is it only me? It's only me, but it's fine. You're doing all right. Struggling a bit, but all right. All right. For the statement v.scale v is scale 5, even though v. All right. What am I doing? I should go back here. Oh my god. So many things about pointers. I hope I don't confuse myself, because honestly, sometimes it's so easy to confuse yourself. You think too much about it. But yeah. This means give me the value of vertex 3.4 in the memory. And this means a memory address of type vertex, basically a pointer of type vertex. That's it. No confusion. Okay, methods and pointer and direction. Comparing the previous two programs, you might notice that functions with a pointer argument must take a pointer, right? So for v vertex, scale function v5, compile error. This is okay. I noticed that. While methods with pointer receivers take either a value or a pointer as the receiver when they are called. So scale 5 is okay. P is equals to %v, right? They either take a value or a pointer as the receiver when they are called. That's what confused me, and ChatGPT didn't give me a proper answer. I think maybe I didn't ask a quick question. Basically, a good question. Basically, it means like you can do an ampersand v, no problem, or you can do a plain value. Uh, let's ask it. So why does this work? This behavior is a good example of how method receivers work in Go, and it's related to value receiver versus pointer receiver. Let's break it down carefully to understand why both work as expected. Here, a scale has a value receiver, right? V. Oh, yes, of course. Of course. Of course. But here, it receives a pointer. Okay, so it must be pointer. Why does both work? This has to do with Go's method promotion behavior for value receivers and pointer receivers. Method 1 with a value receiver, Go allows calling methods with value receivers on both values and pointers. This is something that nobody told me, I think. That's why v dot scale 5 works even though v is not a pointer. This is the confusion that got me, and it's clarified now, I hope. Go automatically copies v when calling the method, so you are working with a copy of v. However, since the scale doesn't return anything, the method just modifies the copy, leaving the original v unchanged. Okay. Method with a pointer receiver. Go allows calling methods with pointer receivers on both values and pointers. This means that even if you have a value v, Go automatically converts it to a pointer when calling methods with a pointer receiver. This happens behind the scenes, and Go is doing it because it recognizes that a scale needs to modify the original object v, so Go automatically takes the address of v and passes a pointer to the method. For a method with a value receiver, you can call it on both a value and a pointer, and Go will automatically handle the difference by making a copy if needed. For a method with a pointer receiver, you can call it on both a value and a pointer, and Go will automatically take the address of the value. Okay. Okay, that was to summarize. Methods and value receivers can be called on both values and pointers, with Go automatically handling the conversion when necessary. Methods with pointer receivers can also be called on both values and pointers, and Go will automatically pass the pointers. Okay, that's the thing. For this statement, v.scale 5, even though v is a value and not a pointer, the method with the pointer receiver is called automatically. This is a convenience. Go interprets the statement v.scale 5 as ampersand v scale 5, since the scale method has a pointer receiver. If I understand correctly, because this has a pointer receiver, it accepts both receiver and a value. If you pass a value, it gets translated into a memory address. If you pass a pointer to it, then yes, it's gonna get translated as well, right? Automatically converted, which it expects, right? So it means it's gonna be referring to the underlying value, basically. That was the confusing part, I think, which we got out of the way. I don't know whoever else is learning programming if they also struggle like me, because to me, yeah, there are two reasons. I'm doing these live streams after work, so I have a full, my brain is already worn out. I have done so much thinking and problem solving, communicating, blah 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 blah, and then I come here and sit in front of the computer and do more stuff. So my mind, the CPU utilization is quite high there, So I might not get the optimal performance. If I would do this in the morning, maybe that would improve. But hey, a night owl can only do things at night, right? Okay, but we are getting there. That's the beauty. We still have one person watching here. Um, okay, okay. And I need to get a water. All right, we are back. We are back. Let's see the Twitch. One person is watching, which is me. Okay. Methods and pointer and direction. 2. This is a continuation of the previous one. The equivalent thing happens in the reverse direction. Functions that takes a value argument must take a value of that specific type. So here we have a var vertex, right? And then if we pass the absolute function v, it's going to be okay. But if we pass a ampersand v, it's going to compile error. Let's see the code here. So here is the absolute, right? Absolute function. Here we obviously we take a value, and if we pass ampersand v here, it's going to compile error because we are taking we are passing a pointer, right? We are passing a pointer. Okay, and compile error. If I move, if I go, where is it? While methods with value receivers take either a value or a pointer as the receiver when they're called, right? Okay. So if we have a fmt, this is gonna be okay. V dot absolute, right? Because this is gonna be a value. This is gonna be a value of absolute, obviously. So we are this is gonna be okay. And then we have a pointer. And if we p dot absolute, also this is okay because absolute here. Where's absolute function? Where's absolute function here? Here. Because here we are because this is a what is it called? What is it called? Receiver. This is called a receiver value. When we deal with receiver values, you can pass both here, both a pointer and a value, and it works. But when we are working with normal function like this, obviously if you pass a percentage v, this is gonna have an error. That's what it's all about. Okay. Choosing a value or a pointer receiver, important. There are two reasons to use a pointer receiver. The first is so that the method can modify the value that its receiver points to. So the first thing is that, hey, if you need to, instead of working with a copy, directly working with the value of the pointer, why not use a pointer receiver? The second is to avoid copying the value on each method call. This can be more efficient if receiver is large extract, for example. Obviously, for each call, you're gonna copy it if you don't use a pointer receiver, right? In general, all methods, okay, in this example, both scale and apps are methods with receiver type vertex, even though the apps method needn't modify its receiver. Where is apps? It's here. So here we have is needn't even a word. And that's need not. The method need not modify the receiver. Okay, here we are receiving a pointer receiver, and here what we are doing is we are defining a v, and that's translating to the memory address of wherever this is going to be stored, like basically the memory address of this vertex. And before scaling, what we need to do, if we do v.apps, right, v.apps, we can do that because we are passing v, right, we are calling v.apps here, and that's totally fine because this is a pointer value, right? This is a pointer receiver, so it accepts a memory address as well. And after that, we v.scale 5, and after scaling, if we call v.apps, right, a scale method, what does it return? It returns a float. So here we are basically passing, it accepts a vertex as well, but we are passing the value, so that works as well, right? That works as well. In general, all methods on a given type should have either a value or a pointer receiver, but not mixture of both. We'll see why over the next few pages. Oh, interfaces. Interfaces. We are in interfaces, guys. Let's go. An interface type is defined as a set of method signatures. A value of interface type can hold any value that implements those methods. This is an error. Okay, an interface type is defined as a set of method signatures. Did you understand that? I know what's a method signature, right? Because we have worked with closures and value functions. A value of interface type can hold any value that implements those methods. Note, there is an error in the example code on line 22. Vertex, the value type, doesn't implement absr because apps method is defined only on vertex pointer. Let's see here. We have a type absr, and this is an interface. Let's explain interfaces in simpler terms, and tell me what purpose do they fulfill. An interface in Go is a type that defines a set of method signatures, behavior, but it doesn't specify the implementation of those methods. Any type that implements all the methods in an interface is said to satisfy the interface. Any type that implements all the methods in an interface is said to satisfy the interface. Okay, think of an interface as a contract or a blueprint. It says any type that has these specific methods can be treated as this interface. So the interface defines the what, the behavior, but not how the behavior is implemented. Key points. An interface doesn't contain data. It just describes the behavior through methods. A type satisfies an interface automatically if it has methods matching the interface. There is no explicit declaration of keywords or keywords needed to say the type satisfies an interface. Interface provides flexibility and polymorphism. You can use different types interchangeably as long as they implement the same set of methods. Example simplified. Let's say you have a speaker interface, right? So we have an est interface. This is how it is called. We have a type and it's the speaker. It's called interface, and it says speak, and it says string, right? I'm thinking that I'm getting this, but let's see. Type person, this is a type person extract name string. This matches, the signature matches what we have here, basically, right? Because we have a name called a string. This is speak function is also probably this is an argument of a string, right? Or a return type of a string. Let's see. The person satisfies this speaker interface because it has a speak method. Function p person speak string returns hello, my name is p.name. So this function implements this interface, right? Because it has a type of person, right? Which has a name of a string. That's a value receiver. That's a value receiver, and it speaks and it returns a string and returns p.name. Okay, so p.name. So we have another type called dog. So breed a string because it has the same structure as this one. This time it's called name. This time it's called breed. Dog also satisfies the speaker interface because it has a speak method. So yeah, so here the speak method a string. Woof, I'm a blah blah blah. Func introduce is of a speaker. It takes a function of type speaker. It takes a speaker type called is.speak. Calls speak on any type that satisfies the speaker. I think I understand it, but let's see. So interface, right? Interface is like this. Let's go back to ChatGPT example, right? So we have a type, and this type is gonna be called what? Speaker, and it's a type of interface. So a speaker, and here is interface, right? The keyword interface. And here we just have a method called speak, which returns a string. So we have a method called speak, which is a type of a string. So any future methods, right, that matches this signature is what? So here we have a interface. Here we have a extract type. Let's say person. This is a extract, and this has a name of a string, right? Okay, and now if we want to implement a method for this person, this is speaker. So basically, if it's a person, depending on what extract it is, this speaker method behaves differently. So for example, if I have a function, right, that takes p of person as a function value, and it is the name of the function is called speak, right? This is the name of the function, which matches here the interface, and it returns a string. All right. Now if I say p string, let's do that. Let's implement that here. Why are we doing that? Okay, let's implement that here. First of all, I'm gonna Okay, okay, guys, we are gonna implement this. We have a type interface. So we have a type called speaker, which is an interface, right? An interface. What does an interface has? It has a method called speak, and this returns a string. All right. Now what we need to do is we need to have a, for example, a person struct, right? And this person struct uh, has a name, right, of type string. And let's say we have a type dog as well, right, struct. This dog has a breed, which is also a string. All right. These are not important, but what's important is here. What happens when we have a function called, which takes a, let's say, p person, right, as a function value, and what is it called? Function value. What is it called? Value receiver. Value receiver value, or value receiver. And here the name of the function is called speak. Okay. And it returns a string. Let's say it doesn't return a string, but it matches the signature. Let's see what happens. fmt dot print ln. What I want to do is I want to say p dot name. I'll just say, well, person's name is p dot name. Okay. And we have another function. This is also takes a receiver value of type. This is also called speak. And this time the behavior of the speak interface changes, because this time we are working with a dog, but the function name still receives and say the dog is of a breed, whatever breed. Here we just say d dot breed, right? Okay. Now these are our methods that we implemented. Now we have a function main. Okay. Now let's initialize this. Let's first initialize the person. So p is gonna be of type person, and let's give it a name. Here, for example, John. All right, and we have a d dog. This is type of dog, and let's say German Shepherd, right? All right. So now what we need to do, if I do fmt dot print line p dot speak no value, use value. What is it? Is it like that? Sorry, this is obviously not curly brackets. And we have d dot speak. So we have p and put d, a function value not called. It's a warning. Can we remove it? Not called. Well, we can call it like that, but it's giving us that little error. What does it say? P dot speak no value, used as value. P dot speak let's go back to our example. All right. So we need to also have this introduce function. Okay, introduce, but we should only yeah. Maybe we didn't specify these, did we? But it doesn't matter, right? Why does it say we still have warnings? fmt.println ln. Okay. Why it doesn't work like that? Okay, let's make that introduce function because why? Because C is func introduce. I don't think this is the problem. Is speaker. Oh, okay. Yes, this is a type of it. It accepts a type of a speaker, and it fmt dot print ln s dot speak. Okay, now here I will just say p dot introduce. Okay. Sorry, not p dot introduce. It's just a speaker. We just need to pass p here and here. Okay. Why though? What am I missing? Oh, because these are return, right? It should be return. It should not be fmt.print. Okay, so that's fine. That's fine. We can do that. We can return. All right. Here plus. Okay. Okay. It just returns a string. Expected semicolon found the dog is a bread. Oh, of course, we need to have a type, right? String type. But still, maybe it's gonna get rid of it. Here also it's gonna be a string. We have a return type. Here we're gonna say return. And here is gonna be replaced with a plus. That didn't have an issue, but here it did. Ah, come on, man. What is this? This is return. I'm just misspelling it. For the person's name is John. The dog is the okay. Okay, we got that. But we had to use this introduce. How can we not use introduce here? A speaker. I think if I don't want to introduce if I don't want to introduce this P and T, well, how can I print them? All right. So I would just say d dot speak. Okay. Yeah, it works like that as well. So I don't need to introduce, right? That makes things, oops, nope, 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 because it returns, but we need to obviously okay. Okay. Oh, I didn't. I just want print with print. Okay, now we're good. Okay, now I can get rid of this confusing speak, right? And get rid of this too as well. Okay, here we go. So we have a interface called speak, and this speaker, the implementation depends on whatever the implementation of this speaker depends on the method, wherever method that implements it, as long as it has a speak name and it returns a string, that's it. You can use this. So here we are defining two values, two types. One is for person, one is for dog. So yeah, right. And then here is the function that we define. It accepts a receiver value of type person, and the function name, as you can see, is speak, and it returns a string. So it means it matches our interface. So it returns a string, because here in our speaker here we need to return a string. Our issue was here we were printing it directly, so that was the problem. And we have another type called dog, another function called type, which also speaks. Yeah, and then this is also going to return a string, so it means it matches the interface signature, and it returns a string. So in our main function, whenever we define our structs like this and we pass this picture, depending on the implementation of each struct type, it returns different values, right? It's called polymorphism, right? It's called polymorphism. Let me explain it here. I think a better example is like, let's say a duck, right, quacks. A dog barks, right? But again, both of these, what does it mean? Like, both of these are types of animals, right? Both of which they somehow express their emotions, right? So now, instead of defining one function for each of them, right? Or yeah, polymorphism, it means poly means multiple. Polymorphism means form, something that can take different forms, right? So in this case, depending on what type of animal it is, obviously we have a type called duck, right? Type called duck. And we have another type called dog. Then we implement the function for both of these depending on the type. When we call this when we call their methods, depending on the implementation, it returns the result. So it means if I in our example as well, right? Instead of let's say this person, what I want to do is I want to say DAC. Let's implement that, right? DAC. So here, what I will do is percentage substitute person with DAC globally. Okay, now we have DAC everywhere, but I want to let's say here at DAC instead of name here, I will just say what is a DAC? What is a DAX? DAX? What is it called? Language. Let's call it language. Lang. Here also, I'm gonna call it lang. A dog lang and a lang means language. I hope this is not a reserved word, but let's see. Okay. Okay, so we have both of type is a string. So we want to know what is the language of a duck and what is the language of a dog. So this one just says let's say I'll just return let's say d, right? D dot lang. All right, and we have here, this is for d, so we will just say d2. It's okay because it's okay, d is okay, it's local anyways. So here I will just say, well, I'll just remove the whole thing and I'll just say d dot lang. Right, so here we are gonna pass one simple string called, for DAC it's gonna be quack, and for dog it's gonna be bark, right? So now if I do a print, what is it gonna happen? Bark, quack, right? So because depending on our type, they speak function difference. So this is a speak function. Basically, if the type is duck is passed, it's gonna be executed, and depending on the properties of that duck, right, which here we define as quack, it's gonna return that. And for dog, the same thing. Polymorphism is a little bit yeah, I don't know, maybe overrated. I don't see it being used a lot in other things. Maybe in bigger problems it is, but yeah. What are some use cases? All right, well this is my implementation, but I want to say let's ask it first of all. Let's give it this. Your code works as expected, but let's break it down to understand what's happening and why it works. Okay, I don't want this. Key points. Okay, what I'll say, oh, give me a real world. Is this called, first of all, polymorphism? What are the real world use cases of polymorphism? Yes, you're describing an example of polymorphism in Go, specifically interface-based polymorphism. What is polymorphism? Is in OOP, polymorphism means many shapes, and it's the ability of different types to be treated as instances of the same type, although a common interface. This allows you to write more flexible and reusable code by making functions or methods methods accept a wide range of types that share a common behavior. Okay, in Go, polymorphism is often achieved through interfaces. If a type implements the method of an interface, it can be treated as an interface type, even if the underlying types are different. This is what you are doing when you're treating both DAC and doc as speaker types, even though they are distinct types. Polymorphism is extremely useful in many software engineering scenarios as it provides flexibility and decouples code. Here are some common real-world use cases of polymorphism. Handling different types of input generic code. In many cases, you may need to write functions that can handle different types of data in a uniform way. Polymorphism allows you to write generic code that works with any type that satisfies a particular interface. Example, logging different types. Imagine you have a logging system that logs different types of messages, strings, integers, or even structured logs. You can define loggable interface and variable and various types can implement it. Very good example. String message, right? String message, log, int message. Yeah. Okay. Polymorphism allows log message to work with both string message and int message type without needing to know their exact type beforehand. User interfaces and event handlers. Many graphical user interfaces and event-driven systems rely heavily on polymorphism. For example, in an app, you may have different types of buttons, checkboxes, or sliders, but you can treat all of them as common interface, say UI element, and can handle their interactions generically. What's my question is actually, but we still need to implement those functions. What I mean is, like, obviously for DAC you still need to implement a function for yeah, I think I understand it now. Maybe that was a wrong question from but yeah, it makes sense. Basically it makes sense. I hope this code makes sense to you as well. So the whole idea is to define an interface, and based on the type of struct that we use, as long as this function is, you see here. Yeah, I think one of my questions is here, these functions can also be normal functions and not value receivers. However, there are important differences between defining these functions as methods with value receivers and normal. Okay, that's called methods. Yeah, that's called methods. And normal functions that are not methods on a type. Let's explore both cases. Currently, you're defining speak as a method on both the DAC and doc types, which means these functions are tied up to the types themselves. They are methods on types. Here is the code behavior. Okay. You can also define speak as normal functions that takes a DAC or a doc as an argument. This would eliminate the need for attaching speak as a method to the types themselves. Instead, you would pass the object as an argument to the function, like this. Differences. Value receivers. Methods are associated with a specific types. This means that you can call them directly on an instance of the type. Yeah, the .lang. When you define methods on a type, Go understands that you can use polymorphism like your speaker interface because methods are tied to the type's behavior. Okay, interesting, right? Interesting. Normal functions are not tied to the methods behaviors, so that's why methods are. Methods can modify the state of receiver if you use a pointer receiver. Example, yes, right. Another thing, right? Normal functions are not tied to a specific type but can accept instances of the type as arguments. They can't directly be used as a part of polymorphism behavior through interfaces. For polymorphism, Go relies on methods attached to the types. Normal functions can modify the internal states of the receiver if the function receives the object. Okay, I understand, I think. Okay. Interface is a type. Interface type is defined as a set of method structures. I don't think we need to read this already because we already know about it. A value of interface type can hold any value that implements those methods. There is an error in this example at code on line 22 vertex. The value type doesn't implement absr because the absr method is defined on vertex, the pointer type. Let's see. On line 22 here, there's a method. We need to first see it. It should return anything that implements this abstraction function as long as it returns a float 64 and as long as it's a method, right? We should be able to. Okay, we have a var called absr, right, which is of type absr here, and then we have a if my float minus. Oh, here my float is because I was getting confused. Let's go further here. So we have type of my float 64. It receives a value receiver and returns this, which is exactly what we implemented. We have a vertex, right? And here we have a function that receives a pointer and returns a float 64, right? Whereas here in our main section, we define this interface and we call the my float and the vertex, all right, two variables. Now we assign a to f, abstract f, my float implementation of abstract because it returns a float, and as you can see, this my float should match this signature because my float exactly returns float 64, right? And it accepts it accepts my float type basically. Okay, so my float, this is math dot is minus math dot is square root of 2, and we have a v vertex 3 and 4. My float implementation of abstract, a vertex implementation of abstract. In the following line, v is a vertex, not vertex, because we assign a to v here. And what was v? V was a vertex. And if I run this, it's going to give me an error. Cannot use v, variable of type vertex, as absr. Obviously, because this one, it's if I put this f, right, it should work because we have here it should return a float 64, but vertex, what does vertex okay, vertex also returns a float, but the value is a pointer. So here if we say it's equals to v, and what is v? V is a vertex. V is a vertex, so this is not a pointer, right? But if I put a ampersand V here, it means it should work. Okay, it's 5. Right? Yes, it should work. Am I correct on that? Because now A is obviously implementing. A is being implemented, but okay, we assign it to a memory address, and memory address of vertex, which is what our function apps expects basically. All right. Okay. Interfaces are implemented implicitly. A type implements an interface by implementing its methods. There is no explicit declaration of intent, no implements keyword. Okay, so we didn't have a implements keyword. Implicit interface decouples the definition of an interface from its implementation, which could then appear in any package without pre-arrangement. So we have a type I is of a type interface, and then we have just this method M, right? And we don't return anything. The type doesn't matter here because, well, the type is not defined. A type implements an interface by implementing its method. There is no explicit declaration of intent, no implements keyword. Implicit interfaces decouple the definition of an interface from its implementation, which could then appear in any prepackaged arrangement. I think I'm gonna stop here, honestly. We are already past 2 hours, and my mind is not working anymore. There are so many things going on, and we learned quite a lot about methods and interfaces, honestly, and I hope whoever is watching this, I know I'm not still a good explainer when it comes to concepts. Plus, I first need to understand them fully and then try to convey the message to you guys. But as a beginner programmer, I struggle quite a lot with the understanding of the concepts itself. Communicating it is completely a different thing. But also my mind is not working because obviously a long day. So I don't want to get myself frustrated by reading and reading over and over again to understand a concept. But so far, I think everything was as I expected it. I hope I understood it. It's gonna come out when we do the exercise. Then we're gonna struggle real hard. All right. So we might need to dive a little bit deeper into this later on in the next stream. But whoever is watching, thank you so much for watching, and thank you so much for staying by. And yeah,